Alright guys, this is Chapter 3, Operations with Rational Numbers. Section 3.1, Fractions and Decimals. In this section we're going to have three new vocabulary terms: terminating decimals, repeating decimals, and bar notation. Okay, so for terminating decimals, any fraction a over b, where b is not equal to 0, can be written as a decimal by dividing the numerator by the denominator. Now to make it clear, I wrote the numerator in red and the denominator in blue. If this division ends or terminates when the remainder is 0, the decimal is said to be a terminating decimal. Okay, so in example 1, we're going to write a fraction as a decimal and see how and why it's called a terminating decimal. Just to be clear, I'm going to underline the numerator in red and the denominator in blue to keep this consistent. Okay, so here I put our numerator, the 7, inside a little house, or you can think of it as a pencil box, and the numerator is telling you how many pencils can fit in your pencil box. I put the denominator, 8, outside of the pencil box. That's how many we're trying to figure out can get in. Alright, so it's how many times 8 can fit into this 7. Well, as you can see, 8 does not go into 7. So we have to expand our pencil box. I added on a few extra zeros because really you can write any number, say 7, as 7 decimal 0000 forever and always until you get tired of adding extra zeros. Okay, after practicing my multiplication tables, I realized that 8 can go into 70 8 times. So I'm going to put an 8 right above that 70 0 point. Alright, and just to remind myself, well, I'll come back to the decimal placement later. So here we have 64 underneath 70, and all you have to do is subtract it to figure out how much is remaining. So I'm going to subtract these, and I'm going to get 6. Okay, so now we have our pencil box that is only 6 availabilities for more pencils. 8 does not go into 6, so I have to drop down another 0, and now it becomes 60. So now I have to use my multiplication skills again to figure out how many times 8 can go into 60. It goes in 7 times, because 8 times 7 is 56. Awesome! Yes! So again, I'm going to subtract these two numbers and figure out what the remainder is. Okay, so my new pencil case is able to hold 4 pencils. Again, 8's not going to be able to go into that 4, so I'm going to borrow another 0, bring that guy down, and so I have 40 as my starting place for my pencil box. Extended my pencil box over there a little bit. Okay, so how many times does 8 go into 40? Oh, magical math and multiplication skills gives me 40. Goes in exactly 40, and that's 5 times. Put my 5 above that 0 I borrowed, and look at that, 0 remainder. Got exactly the right number of pencils, nothing left over, so there is my answer. Okay, so where do I put my decimal point? It's going to go right where to the left of that first number. Right? Here was the one I started with, and this is where I'm going to put it. So my final answer is going to be 0.875. So to repeat this, I did 8 times 8 to get 64. That's where this 8 came from. I did 8 times 7 to get this 56. That's where this 7 came from. And I did 8 times 5 to get this 40. That's where the 5 came from. And finally, it's terminating because no matter how many zeros I borrow, 8 is never going to be able to go into that. So it terminates. Okay, so repeating decimals and bar notation. Repeating decimals have a pattern in their digits that repeats without end. Bar notation is a bar or line placed over the digit or digits that repeats. I'm going to do the first one for you, and then you're going to try the next 3. Here we go. Okay, on the first one, where the decimal says 0.1666666 forever and always, the bar notation is 0.16 with a bar over the 6 because the 6 repeats forever. Now it's your turn. Try and put the bar notation for each of the remaining 3 decimals. Do 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 do. Okay, for the second one, it was 0.35 with the 3-5 continuing on forever. The third one, it was 12.68. I put a bar over the 8 because the 8 repeats forever. And the last one was kind of tricky. It's 5.714285 repeating on forever. So I put a bar over from the 7 to the 5. So that number series will actually continue to repeat forever. Okay, so in this example 2, we're going to write fractions as repeating decimals. So we're going to see 2 problems, A and B, and in each we're going to write the fraction as a decimal. Now to do it completely, we're going to use bar notation to show where the repeating decimal takes place. So pause right now because I am going to show you the answers in a few seconds. Do 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 do. All right, pause. Make sure you pause. Okay, for problem A, 5/12, often you'll see it as 5/12. Okay, I put 5 in my pencil box and 12 outside of that. 12 did not go into my 5, so I borrowed a 0. Because of that, I put the decimal up over to the left, and 12 goes into 50 4 times, so I multiply 12 by 4, I get 48, and then I subtract and get 2. So 12 doesn't go into 20 once, so I put my 1 up there next to the 4, and then I multiply 12 by 1, drop my 12 down, and I have a remainder of 8. Okay, so finally, here we go. We drop another 0. Notice I added on a few extra zeros because, as I said, you can add on as many zeros as you want, because 5 is still going to be 5 if you add on those .00000. So 12 doesn't go into 8, so I borrowed my 0, and now it's 80. How many times does 12 go into 80? Well, I put 72 because 12 times 6 is 72, and if I add another 12, it won't fit into 80. And I'm left over with another 8. So that's interesting because that shows me that I have 8, so I know the next one, I'm going to have to, when I borrow a 0, it's going to be 80 again, and that's going to be 6, and this 6 is actually going to repeat forever and ever. So my final answer for this is going to be 0.41 with the bar over it, because the 6 is going to continue or repeat. Okay, on this second problem, problem B, I wrote it out already in 2 steps. Alright, we have to remember, oh, and look, I forgot that this was negative. Our answer is going to be negative 0.18 with a bar over the 1 and the 8. Now why? Well, because we first did our borrowing of our 0 to make 11 go into 20. That went in once. I dropped the 9 as the leftover. Borrowed another 0. 11 went into 90 8 times, so I dropped my 88 there, find what the new pencil box size is, which happens to be 2. Oh, and then I'm back where I started, right at 2. And it will repeat. You can see that. So my final answer is going to be negative 0.18 with the bar over the 1 and the 8. Okay, in example 3, we're going to write a fraction as a decimal. According to the United States Department of Agriculture, the USDA, teenage boys should consume an average of 2,700 calories per day. About 370 calories should come from a calcium source, such as milk. To the nearest hundredth, what part of a teenage boy's total calories should come from milk? Okay, so I underlined some important things. 2,700 is going to be my total per day, and 370 is going to be the calcium source coming from milk. So here I have my denominator and numerator, and that's my fraction. I also underlined nearest hundredth because that's what my answer wants to come to. Not the thousandth or 10,000th, but that second decimal place, which is 100th. Okay, so these are big numbers, but let's see if we can follow the same principle and get to the answer. Pause if you want, and try it on your own. Sorry there, I made a mistake. It's actually 360 calories should come from milk, so I replaced each 7 with a 6. Make sure you do so yourself. Okay, so after that little slip up, if we finish out this problem, we're going to see that 2700 goes into 3600 one time, which is pretty simple. We can just write it out. Our remainder from that's going to be 900. That's our new pencil box size. That, again, is not large enough for our 2700, so we borrow another 0, make it 9,000. Now we have to do a little bit more math, and we find out that 2700 will go into that 3 times. That's where our 3 up there came from. And that's going to equal 8100. And again, we have a remainder of 900. Oh, here's our pattern. It's going to keep continuing on and on with going in 3 times. So our final answer is going to be 0.13 with a bar over the 3, because it's repeating. For example 4, we're going to compare fractions and decimals to see which one's greater than, equal than, or equal to. So here we're going to replace the circle symbol with a greater than, less than, or equal to make the sentence true. See if you can convert it on your own. So pause right now, and then we'll go over to the problem together. Okay, so here we see the first problem. 1/4 is equal to 0.25. So I made a greater than sign chomping on the 1/4. And I think of it as alligators always like to eat the larger food source, so give it little teeth. There we go. So if I do our division correctly, we'll see that -5/8 is equal to 0.625, or -6.625, and -6/9 is equal to -0.6 with the bar over it. This is also called vincular, but we'll come back to that. So if it wasn't negative, 6/9 would actually be larger, but because it's negative, 0.625 is closer to 0, so that's the way that our symbol is going to chomp down on. Okay, so in example 5, we're going to compare fractions again using decimals. So this one's about fundraising. 30 out of 36 parents or guardians participated in the fall fair last year. 34 out of 40 parents or guardians participated 2 years ago. So which 7th grade class had a greater parent-guardian participation for the fall fair? So we take a look at this. I underlined the first year, just last year, and then underlined 2 years ago. So it's 30 out of 36 or 34 out of 40. Using decimals, we're going to figure out which one had better participation or greater participation. Okay, take a moment to try these on your own. Okay, so taking a look at our first one, we see that we have 30 over 36. And if we do it out the math, 8 times 36 is going to get us 288. That gives us a remainder of 12. We bring down another 0. That goes in 3 times. We have 108, and we come back to 12. So right there we know that we have 12 again after doing how many times 36 can go in and borrowing our 0. So that 3 is going to repeat continuously. So our final answer for this is going to be 0.83 with the bar over the 3. So in the second one, we look back at 34 over 40. We have to add another 0 to our 34 because 40 doesn't go into that. We multiply 40 by 8 because that's how many times 40 will go into 340, which happens to be equal to 320. We subtract those, we get 20. Again, 40 is not going to go into 20, so we borrow another 0. We're at 200. We've had to